Hello everyone. Welcome to today's lesson on Newton's laws of motion. We're about to plunge into an exciting exploration of the world of physics, using the pioneering work of Sir Isaac Newton as our guide. Prepare yourself for a journey into the heart of scientific discovery and intellectual curiosity. This magnificent adventure begins with the incomparable Sir Isaac Newton. A man of exceptional brilliance, his insights revolutionized our understanding of the universe. He was not just any scientist, but one whose contributions have left an indelible mark on the field of science. Newton's intellect and innovative thinking were recognized by his society, earning him a knighthood. His work formed the foundation of modern physics, and his influence continues to be felt today. The title Sir is therefore not just a formality, but a testament to his greatness. His contributions to the world of science were truly remarkable. Sir Isaac Newton, a highly esteemed and influential physicist and mathematician, introduced us to three fundamental laws that provide an in-depth explanation of how forces in motion are interconnected with the fabric of matter. His insightful laws, even after centuries, maintain a prominent position in modern science. They are widely acknowledged and still in use today, underpinning the core principles of classical mechanics. Now let's delve into these laws more closely, understanding them one by one. Newton's first law, often referred to as the law of inertia, is the initial one in the series. It is a fundamental concept that a fundamental understanding of motion. It proposes that an object at rest will persist in its state of rest unless it is compelled to change its state by an external and unbalanced force. This law essentially means that objects have a natural tendency to keep on doing what they're already doing. In simple and relatable terminology, it can be said that things, be it objects or creatures, exhibit a natural preference for maintaining their current state, whether that is at rest or in motion. They will continue to remain in their existing state unless some external force compels them to alter their state or behavior. Now, let's move on to Newton's second law. This is a vital principle in the realm of physics that has profound implications on our understanding of how the universe behaves. Simply put, this law is a rule that describes the relationship between an object's motion, the forces acting upon it, and its mass. It says that the acceleration of an object, how quickly it changes its speed, depends on the force applied to it and its mass, its amount of matter. The direction of the acceleration is the same as the direction of the force. The force and the acceleration are directly related. If you increase the force, you increase the acceleration. Conversely, the mass and the acceleration inversely related. The more massive an object, the smaller its acceleration. So the more force you apply to an object and the less massive it is, the more it accelerates. In other words, the bigger the force and the smaller the mass, the faster an object will accelerate. Finally, we have Newton's third law, which is one of my favorites. This integral part of the realm of physics is intriguing in its simplicity and profundity. The law posits, for every action there is an equal and opposite reaction. Consider the sheer beauty of this principle. It's a dance of forces, a cosmic ballet where push meets pull. Imagine a scenario. You exert force on an object, pushing it. Instantaneously, that object retaliates, pushing back with an equal intensity, but in a contrasting direction. It's the universe maintaining balance, a perfect harmony of forces. To showcase Newton's third law, let's delve into its application in aviation, particularly how it assists in counteracting gravitational forces to enable flight. Let's consider an airplane's wing as a principal example. You know that feeling when you stick your hand out of a car window while it's in motion? If you ever tried to position your hand at a slight upward angle, your palm facing forward and your fingers extended out, you've likely noted that your hand rises. It's pushed up by the wind. That's a basic demonstration of Newton's third law in action. The wind opposing your hand is the action force, and the resultant upward movement of your hand is the corresponding reaction force. This is exactly how an airplane takes advantage of these underlying physical laws to take flight. Now, imagine an airplane's wing in the same scenario. When the wing is oriented at a slight upward angle, it interacts with the oncoming air In a similar manner as your hand did, the oncoming air, or the airflow, exerts a force on the wing of the plane. The wing, being angled slightly upwards, creates a reaction to this action. The action here is the applied by the oncoming air on the wing, and the reaction is the lift that the wing experiences from the oncoming air. It's this upward reaction, the lift, which is instrumental in keeping the plane airborne. What's important to understand here is that this lift generated is directly attributed to Newton's third law, which states that for every action, there is an equal and opposite reaction. The airplane's wing, when angled slightly upward, also receives some of its lift from the oncoming air. The airflow is the action, and the reaction it provides is the lift that keeps the plane in the air. So there you have it, the astonishing universe of Newton's laws of motion. These laws are not merely scientific theories, but the very framework that defines our understanding of movement and of objects. We've delved deep into how these laws articulate the core principles of motion, the concept of acceleration, and even the seemingly magical phenomenon of how airplanes defy the pull of gravity. These principles, unearthed by the great mind of Sir Isaac Newton, serve as the bedrock numerous concepts in the vast realm of physics. They have not only revolutionized science, but also have a profound influence on modern technology. These laws are not just confined to textbooks, but are in action every second of our lives. Be it the thrill of playing sports, the simple act of walking, or even the rhythmic beating of your heart, these laws govern them all. Physics is not an abstract science that is far removed from our lives. It is in the air we breathe, the ground we walk on, and the world we perceive. Understanding these laws and concepts aids us in comprehending the world on level. So, as we conclude this journey into the world of physics, I encourage you to think about how these laws apply to your everyday life. Physics is all around us, and understanding these laws helps us make sense of the world.